So next we're going to talk about density and the temperature relation and how that plays into density, as well as the ability to conduct electricity of various like substances while in water. So I guess we'll just start off with this.
Don't laugh. I thought you were erasing it. I was like,
I have a question.
Huh?
Salt water is really like it conducts electricity.
shocking, isn't it?
Yeah.
That's so corny.
So is tap water, because tap water also has like minerals and stuff.
So if you tap the water with a wire, it's gonna be like.
She said if you tap the water with the wire.
Okay.
Water from from the tap. Okay. So sugar doesn't conduct anything.
Why? I just asked why.
I can't tell you why. Salt is
NaCl.
It's a mixture.
what is Na?
Sodium.
What is Cl?
Chlorine.
And both of those are,
Elements.
and one is,
Not
Non-metal.
and one is.
Metal.
What do metals do?
Conduct electricity.
Thank you, teacher
Alexis.
Thanks, Miss Thomas.
Okay, don't touch me.
She just said
Okay.
you never get married.
What is that?
So-
Does that say brine?
Brine, yeah.
What's brine? Like,
Thank you, teacher
Alexis.
Thanks, Miss Thomas.
Okay, don't touch me.
she just said
Okay.
you never get married.
What is that?
So-
Does that say brine?
Brine, yeah.
What's brine? Like sea stuff?
So brine conducts electricity,
Okay, anyway.
and cooking oil doesn't. And cooking oil isn't even like
Why?
soluble in water.
Because it's an
anyway.
oil.
Yeah.
Oil and water. They go together like oil and water. AKA they don't.
What?
And then I already talked about that water. So with density, the higher the temperature, the faster the molecules, which equals to like, it's like, think of water getting hotter and then like becoming a vapor or a steam. And so those molecules just like spread out and bounce around. So there's less in a volume, I guess you could say, of like a certain like set volume. Then when things get like frozen, and water's not a good example of that because frozen water is ice and it floats anyway. But like if it were something else, like I guess a syrup that were frozen, it'd be denser because the molecules would slow down and it would just like solidify.
But would that have to do with anything with the viscosity of, like, because syrup is thicker while air is not?
Syrup can't even like become a vapor, can it?
I don't know.
Well, if you leave it out,
If you heat it,
yeah.
if you heat it up enough, I mean, what did you think? Because it's a liquid.
But there's other things in there, so the liquid part of it would evaporate. Yeah.
Okay, I'm just wondering.
Okay. Okay, we're done. Okay, so finally we have the conservation of mass and balancing equation. So, assuming that, let's just say the containers weigh nothing, just for this little, like, demonstration, the conservation of mass thing says that you have to have, like, the same stuff, or have, like, you can't, like, destroy mass.
Yeah.
It's there.
No matter how much, they're always going to be equal.
If it's like the same stuff. If you're like weighing a cat and a dog, then that's going to be different. But if it's like a cat and a cat, let's just assume that the cat's going to have the same amount of like characteristics.
Pause it. Stop.
Stop it.
Well,
Our lovely artist is drawing acids and bases.
Acids.
Don't make fun of me.
Too late.
I will talk to you about them. There's different types of acids and bases because it depends on their.
You said basics.
Depends on their pH level, which is a scale from 1 to 14. 7 being the neutral term. 1 through 7 is.
Is this okay? Or will anyone else laugh?
That's-
Okay,
1 through 7 is acids, right?
Yeah.
Okay, and 7 through 14 are bases. So that's easy enough to remember.
Can I have an example of both, please?
I'll give you tons of examples of both. Okay. Oven cleaner, drain cleaner, baking soda, and bleach are all bases
Why?
because they have a pH level above 7. Our cherry, lime, and lemon are all acids.
Why? Will they burn through your skin?
Well, some acids will, like hydrochloric. Well, acids taste sour. Bases taste bitter.
Like soap.
Yeah. Acids turn blue litmus paper red, right?
It's just litmus.
It's regular litmus paper?
It's just litmus.
It's just
paper.
litmus paper? Well, they turn it red.
Whatever
And-
that is.
Well, bases keep it blue. So it's just normal. So you can remember as bases blue bitter. And well, you gotta remember acids.
And acids red sour.
Yeah, because that's not an acronym. Or okay. You want to explain to them about the difference between physical and chemical changes?
Okay. Physical changes are purely outside, like H2O is still H2O whether it is in ice form or liquid form. Whereas, like, the reactions inside of firework with, like, gunpowder and everything, that's a chemical change. At first, it's just, like, it all is, like, just, like, sitting there, but then I guess, wasn't it, like...
I'm sorry, I got hair in my mouth. Yes.
So the fire burns through it, and then it ignites the fuse, and then it catches fire, and then it goes up to the sky, and then it explodes in the sky. And that's basically how the chemical changes work.
Yeah.
Oh, wait, we didn't talk about what happens when we bring acids and bases together. Bases and acids together. And that's, usually they'll, like, bubble up and get really hot, basically. They, like, froth, and then there's bubbles, and then it's, like, super hot, and then things explode. So, yeah, you can't destroy, mass or matter. But, assuming that these containers don't weigh anything, H2O, and then if you have two separate containers of H2 and O, they're going to weigh the same. They're going to be equal. So,
Because they're made up the same thing?
Mm-hmm.
Okay.
And so, on balancing equations, you have to see, like, you have to make these two things equal. Which kind of, you know, comes into the conservation of mass. But, if you have, like, zinc and then hydrogen chloride, I guess is what you might call it. Chloride, okay. And then if you have zinc chloride, dichloride, there's two chlorides.
Yeah. I think
And then two hydrogen thingies. You'd have to somehow make these two equal, because you only have H over here and then two H's over here, so that's not equal. So to make these two equal, you can see that Cl also has 2, which I just erased, and then H also has 2. So you could easily just put in a 2. Well, that's really bad. Turn it to me so I can write it. 2. Okay. You can easily just put in 2, so you have H2, Cl2, and these two would be equal because you still have one zinc, and then bless you, and then you still have your hydrogen and your chloride, but you have 2 and they equate. So, yeah, that's